Yes, ma'am, you can start.
Okay. So, good evening, one and all. Present in this 6 days online ATAL faculty development program on quantum edge intelligence, organized by Department of Computer Science and Engineering, MCKVIE Institute of Engineering. On behalf of this organizing committee, I, Dr. Sasmita Subhadarshini Chaudhary, welcome all the participants and the speaker of this session. So we are very much fortunate to have with us the speaker of this session, who is the CEO of an international repute, co-founder and a good mentor. He is none other than Dr. Sabyasachi Saha. Dr. Sabyasachi Saha completed his PhD in generative AI, specializing in sentiment analysis from SSBM University. He is the CEO and co-founder of Techno Exponent, a globally recognized IT company with more than 400 employees and which is present in different countries throughout the world. He is also the co-founder of Euphoria Gen X, a visionary tech entrepreneur with more than 15 years of experience in artificial intelligence, machine learning, blockchain, cloud architecture, and digital strategy. Dr. Saha is renowned for transforming innovative ideas into scalable business solutions, establishing strategic partnerships, and driving operational excellence. His primary areas of competence are business strategy, process optimization, and AI-driven innovation. He has significant leadership experience, growing international teams, and guaranteeing outstanding client satisfaction. He has significant number of publications in different international repute journals. He has received Most Influential Young Leader Award in 2021, 2022, Asia 1, and the Economic Times. He was associated with notable projects such as Doredo AI-powered education platform for personalized learning, the Miracle-led development of Brilliant AR Studio, VS Code extension, connectivity optimization, feature addition, etc. In LifeForce, React.js-based healthcare, web app for booking doctor's appointments, and many more projects. Regarding his leadership quality, he grew Techno Exponent from a team of 3 people to 400 plus expert professionals. He mentors young tech talent through Euphoria Gen X, trained more than 10,000 students to make them job ready. He delivered more than 4,000 successful projects to 2,000 global clients, including Disney, Amazon, Forbes, NASA engineers, and the Wall Street Journal. He turns Techno Exponent from an entrepreneurial venture to an award-winning, globally recognized IT company. Today, he will deliver his lecture on synergizing cloud infrastructure and edge computing for next-gen applications. A hearty welcome to you, sir. Dr. Saha, please.
Thank you, ma'am, for giving such excellent background about myself. So I just shared my screen to directly come on to the topic, because this topic is quite interesting, and this having a lot of real case scenarios which I'm excited to talk. So without further delay, I just start directly onto the topic. Just student, I wanted to let you know, like, if you all see my presentations, the window, or
Yes, sir.
okay,
Yes, sir, it
okay.
is visible.
Okay, you see my only one window, right? Like where it's showing like Synergizing, Cloud Edge. That's only one.
Right, sir.
Okay, okay, perfect. Okay, so let me directly come. Let me move those things to around. Okay, so today's topic is very relevant in nowadays, and I wanted to give you an examples of a problem, because I always first start to talk about the problem and how, because we engineers are actually born for problem solving. That's my say to all of our people, the engineering community. So whatever the problem is there, we need to solve it. That is our goal point should be there. So a real case problem I want to start, and I want to tell how Techno Exponent is solving that problem. So there is one specific problem has come into our forte. So the problem is that the client has a lot of cameras. So nearly 10,000 plus cameras the client has. Now, what client is expecting from us? Client is expecting from us like if any of that camera of a big building, if any security mishaps happens, say for example, any persons comes through the gun, any persons fall down, any kidnapping happening, or let's imagine someone is using a lot of mobile phone in the working hours. So all would be catched and it will be notified to respective department. That is a real scenario of problem statement. And just for the viewers expectation here, this is a very this is a very competitive problem, I must say, because of say for example in your college campus drive there are, let's say, 100 cameras. Now there are someone who are monitoring those cameras. In our office premises also there are 15-20 cameras over there, and there are someone there who is monitoring this. Now problem is that it's very hard to monitor every time 24 hours 7 days in a week if some mishap is happening or not. Okay, because if just imagine if there are 100 cameras, so one people cannot monitor those 100 cameras. Okay, so we need more and more people over there. Now you may say, okay, that's great. The problem statement could be solved easily through AI. Of course, using AI and cloud, it can be solved. So say, for example, we get the video feeds, and after getting the video feeds, we analyze that, okay, if there are someone containing guns or not, someone suddenly falls down or not, someone is, stealing something or not, okay. Or say, for example, some of the people are maybe has come to that particular store before and took something, theft something. If that person comes to their immediate detection, that can be done. But just example that, so just to know, like we can send those record from the camera, send to the cloud analyze that and send back to there. It may take time. It may take a lot of times to do it, this processing it. Now, using Edge, we can do it easily. So Edge is a thing which do it locally, and if the decision is verified, it's okay. If not, then send back to the client. So you can find out a local scenarios. So the problem statement, what I was saying about the AI security camera, when you build into the cloud infrastructure caused gone so high, almost like 27,000 US dollar the AWS cost was there, which is totally crazy, and client totally been unhappy, like that cannot be done. Then we start optimizing the project. Many of the sector we put it into the edge computings, and once we did in the edge, then it become fast, and the app, our mobile app and web app, it become very powerful. So today, starting of the context, I will be deep driving to you, and I will encourage the student to understand between cloud and edge in a real scenario, that how we can do it. Okay, student, you got it? Any questions so far what I said?
Sir, this is faculty development program.
Oh, sorry, ma'am. So all 86 faculties are there?
All, yes.
Great.
All of them are
Uh,
faculty, sir.
Great. Okay, that's great. Thanks for faculties
And
to be there.
some are research scholar and PG scholar.
Great. Okay.
Mostly
So I
faculty.
think, yeah, okay, great. Because 86 number, I thought, I know there will be some faculties, but 86 numbers there, so I was quite surprised. That's great, because few days
Actually,
back I gone to
126 faculties had joined the program.
Okay. That's great. Okay, because IIT I went there, I got it like nearly 43 faculties, so that's good. But anyone, all the teachers, faculties, just for my apologies. So you all understand, right, what I'm trying to say here? Any questions so far? The problem statement? Okay, let's go straight forward. So, this is my research already been said. I'm skipping the slides and I'm going to the next one. So say for example, like first of the problem statement, I simply want to explain here. Just give me a moment. I put it over here. Yeah. Okay, so just give me a moment. So okay, so first, I'm giving an examples for simple understanding how we can make the situation little bit in a mode of sandwich. So in the sandwich mode, why I'm taking the example of sandwich mode to give you an understanding. So sandwich, there are three slides we can talk about. Number one is the first, slides. Second is like you can say like all the putting over there which you put in middle, and third one we can talk about like the third bit. So first bit which is there, that we can call edge, which is very near to the device. So it may be like a laptop, in computer and things like that. So we can call it like a in a device. And the second, which is the making the putting between those two braid, that is we can call as a you can say it as an edge. So it's just having a connectivity. And last one is the cloud. So edge, what is doing, it making a quick reflex. So giving an example, say for example, we have a Raspberry Pi devices. So that Raspberry Pi devices can directly connect to the any of the edge computing, and we can program over there. Let's imagine we can do through MicroPython, or maybe we can do through C++. We can write our code over there, and that specific code can directly connect to that device itself. You may remember, or some of you may, I told you before as well. So recently we built a project called Monocle. So in Monocle, what we are doing, there is a sunglass we have built, and in that particular sunglass, if you see some of the food or anything, then you directly getting like what that food all about. How we are doing? We are doing through the edge. So we simply getting the images. We have our small model being trained, because large model we need to train to the cloud, but a small model which we train to the cloud, we create a lower version of that particular model and we put into that particular devices, and that devices actually check like what that food is and instantly give you an answer what that food is. And if this is not been recognized, then it's sent to the cloud. So you can say in a who knows bit of cloud mode, so they can say like a cache memory. So we can say about edge as a cache memory. It's not exactly as a cache memory, because cache memory is something which been searched, which data been processed, those we send to the cache memory. But edge itself a decision maker, edge itself has all kind of small model can be put on, small data can be put on, but you can think the concept wise, this is kind of a cache memory, so which actually can get the data and just if it is verified, then it sends to the response back. If not, then it's sent to the cloud. So let's imagine another real case problem, and I want to solve it like how edge and cloud is different. So let's imagine the face recognition device. In our campus, in our offices, face recognition device is there. So what we are doing, we are going to the in front of a face recognition device, and our face is detected immediately. If it gone through the cloud, it will take much more time, because our face picture is gone, then encrypted format it should be sent to the cloud. There is a cloud model that's verified, and after verification it's sent back, and after sending back whether my face, I'm Dr. Saha or not, that would be verified. Whether I'm authorized to enter or not, then only I could enter. But edge, what is doing, it has a small model, inference of all the part. Just give me a moment. Yeah, inference of all the part, And then after that, what is happening, like it's simply checking whether I'm that person or not. And once the person is matching, then it's giving me enter and save my record into the cloud. So that's the difference between cloud and edge. Cloud, we can say big brain, which is far away. Edge is quick reflex and near to the users. So far, any questions you have? I just wanted to put step by step so you get a clear picture of that. So it's give you a proper understanding. Can we proceed through?
Sir, please.
Okay, thank you. Okay, now why should we care? That is very important. Most of the time I found, like when you teachers are going to talk to the student, and I would request them, I have, as you know, like I have connected, as we hired the students from different engineering colleges, experience. So I mostly found they are yet not accustomed with socket, MQTT, those kind of thing, which is a part of edge. Edge is a big term, it feel like a big things, but it start with very small. But MQTT, socket, WebSocket, those things are not very accustomed. Some of the cases maybe teachers are teaching them like a socket, MQTT, sending response and things like that. But this is not all about they know. So, and that's the reason many times the app they build, those are very slow. Just giving you an example of a socket chat application. So chat application recently many people are doing through socket, but previously many people used to do like I send hi. It goes to the, in many project I have seen, in a college project I'm talking about, I have seen. So I send hi, it's sent stored to the database. From database it fetch, and then receiver side it receives it. Now it's very you can say like a very slow ways to work, because there's a REST API getting called, and when REST API getting called, it takes so much time. Now imagine that instead of that, we simply make like a emitter and listener, which is a socket or MQTT concept. So emitter is what? Let's say me and another user or a group of person are making a chat. So what we should do, we simply put like a hi. As soon as we put hi, then it actually through a secret channel, it just deployed to the, you can say like that particular channel, and other receiver actually, they just get the response and they see, okay, we are all are here getting a response hi, and then responds back hello, and it sends back to the sender. But in the background of the process, we are making the database operations. What extra facilities we are getting? We are getting extra facilities like a fast. And what more, our sending data, that cost getting low. We don't have that much of data sending cost over there. Another thing is there, the privacy. So this is not the chat example is the ideal example, is not ideal example for a privacy, but for a face detection, it's ideal examples, because every time you detect the face, and then you verify through a secure channel to your cloud and then send back, then it may happen that it's take a lot of time. And every time if you send through a secure channel, it may not be possible, and it may be a lot of costlier way to do. So instead of that, what we can do it locally, we save it locally, and we send it through a secure channel. So it actually giving you a better privacy. So for 3 reasons, we should care about this edge part, because that gives you a 3 things better: faster app, lower cost, and a better privacy. Okay, let's move forward to this. Now, I understand that what is edge now, or bit of understanding about edge, but I will obviously come through what is edge. But what is cloud first? So some cloud is one of the important part in our software development. Specifically, cloud we can say like where is a for heavy work, for heavy storage, and for of course like a little more latency is there. So though different approach we use to make the latency down, but still high latency is over there. So let's say you are training a big model. So say for example, I'm working with Boston Children's Hospital, making a heart surgery easier. So we have a lot of DICOM images. So those are DICOM images when we are training. So we are training through cloud. So we are training those in cloud, because in a edge computing, those not possible to train. So we have to train through the cloud. So there are, high GPU you are using, then Tesla GPU you are using, huge storage we are using, those huge storage we are keeping, and then, we are training those data sets. So that's, we can say, like, for this we need like a cloud. But for infra part, so when we build the model, that model we can even build to the edge into the local system for better to reduce the latency or better throughput. So cloud, so now when I will be using cloud, so these are big questions can come from the any of the community. So cloud actually can come through, only we need like when the heavy storage, heavy training, or keeping data for, or processing data through maybe few years data, or maybe we have to fetch data from a different record. For those purposes we use cloud. Now coming to the point is, what is edge in that case? So edge actually for the quick responses. So say for example, like a UPI payment we are doing. So you can find out like when you are doing UPI payment, so if our internet is slow, then also we can make the password, we put like a password, it automatically validates, it doesn't take time. But yes, banking information to load, it takes time, but we just put the password, if it's wrong password, it immediately tells. So that can be, so that is one of the examples of another example of edge. So basically for quick response and offline uses we can do it. So, and of course like limited power. Now many of the questions can come like what is the offline uses and how edge is helping. So offline uses in the phone, when we are using our phone, we put some information, or maybe some kiosk devices are there in a hospital or in other places. So let's say we put our information and we save it. So in local database it saves it, and when we have the online connectivity, so it saves to the cloud. So those are the offline uses, and they are actually edge is very handy and helpful. So now I make a little difference between cloud and edge. What is the exact difference between them? So if I consider about the specific use cases, so cloud is something where we have a heavy processing, and through secure data channel we send to the cloud, and edge is very near to the device, which directly responds back to the to the computers or to the devices, like to the mobile, to the kiosk devices, etc. And why it's useful? Because most of the time right now we are using kiosk devices, we are using mobile and computers, those things, and saving record into the local. That's very important to have like a edge to our groups. Now also technical questions can come, like what exactly we should use for edge, what kind of programming language we can use for it. I will be talking to the architecture part a little later on. That would be handy for all of the teachers present here, of the faculty present here. They can actually train their student on that particular part. Let's move forward, like 3 layers. So that particular part I wanted to talk about. So a simple picture of 3 layers. So one is like a device interaction point, second is the edge, third is the cloud. So I given you example of sandwich actually. So first one is a device interaction point, first bit is a device point, the middle portion is the edge, which is local processing, and third is the cloud, like a heavy computations. So those things been there. So say for example, we have to make a decision. In my home I have built a small system 2-3 years back. So maybe 3-4 years back, a very small system. So whenever a rain happening, so automatically Windows curtain will be close down. So it's a very simple, things. So I made like a Raspberry Pi, one of the devices we have used, and that has a sensor been connected with that. And what happening, like it just detecting the rain water over there, and as soon as the water has there, so it just processing through, and it's giving the signal to the our so to the cloud part, and it just closing down the curtain. So this is simple. We can talk about edge part, and cloud is something where we can have like fetching the data from historical data, show the dashboard, make the database operations. So there we can put to the cloud things. Similar way, another example I can give you, like a POS system. We all accustomed with the POS system. When you go to the shopping mall and things like that, we simply have the POS system where simply detect the devices, the products. It scan the QR code and it's saved to there, so we can find out in a edge computing over there. And when all the billing and everything been done, then it saves to the cloud database. So if cloud doesn't work in that case, so we simply like save into the local, and then when the network comes back, we save into the cloud. So that kind of examples we can use about those three layers. Now, next pointer there, like when actually we will be using edge and when we will be using cloud. So let's say a robot arm need to stop. So what we will do? Cloud? Of course not. We'll be using edge. Or let's say drone. A drone is flying. So drone need to see whether there is a tree or not, or whether there is a kind of a obstacle or not. That always will be see through like a edge. But a aeroplane is going, so it has a long map been plotted, and that maybe come through the cloud, because there's a route and everything. It's not instant update because there is no obstacle and things like that. So that might be coming through the cloud. So that's a bit of difference over there. So specifically, like when we need to do through the less than 100 millisecond, very fast response need to be there. So we will be using edge. But when we need show the dashboard, or analyze the historical data, then we use the cloud. So that way we can define like when we will be using edge. Now, when we will be using cloud, edge we understand, but when we will be using cloud. So I can give you an examples, like let's imagine that your universities has like 10 different cameras, or maybe there are 10 building over there, and then you need to see the big pictures, or maybe like you have to have like a yearly admission data you need to see. You need to find out like which cities the most admissions happens. So in your college, like from which cities most students comes, and you need to take a decision of your marketing that okay, maybe from Bardhaman you are getting a lot of candidates, or let's say Mendipur you are getting a lot of candidates, or maybe Kolkata you are getting a lot of candidates. So your advertisement model should be that specific area. So those analysis should be done through the cloud. So those things be to the cloud. So basically like analytic data, or big model training, store a lot of data, those things we will be using cloud. Rest we can use edge. So far, any questions? Because next slides I will be going through some of the more scenarios of specifically like golden rules, and then I will be coming to the patterns. So any of the questions so far you have? Okay, let's proceed through. So there are two more things over there. Like one is the golden rules. So what is that actually? What I mean by that? So say for example, there are a bus stop is there, or there are a kitchens are there. There is a CCTV camera being put up, and then we simply need to find out that how many person is there into the bus stop, or how many say for example, how many students are there into that particular say for example the cafeteria area. So for that, do we need to process through a whole video? So our CCTV is just processing through the whole video. Do we need to process through the whole video? Answer is simply no. We don't need to process the whole video. What we need to do? We simply need to take the snap of the images. And through the snap of the images, we can find out how many people over there. So that we can talk about like like we can do like through age, or say for example like you have to find out like if temperature are in 27 degrees Celsius, then you need to send a response somewhere, or temperature is 30 degrees Celsius, then you need to send response. So you don't need to send the minute and minute data to the cloud. Simply you find like okay, this is a 30 degrees Celsius right now, the alarm being set. So if the temperature right now 30 degrees Celsius, so you send alarm through MQTT or socket or whatever the emitter channels you do it. So that's simple like age and filter kind of concept. So there we use so fast and nearby. That's normally we use for the sensor, age part. Now if I talk about the cloud, so cloud again, like if you having like heavy data sets, or you need to go for a long run. So say for example, you need to validate the data, you need to validate the pattern, then you need to have to the cloud learn. But I will be talking about there are also the edge can learn through the cloud, a smaller version of that, which you can call as a small LLM, not large LLM. So small LLM we can use as a edge computing also, we can do it. So I'll be coming to the point of that. So say for example, like pattern 1, filter and forward. So what is that? So as I explained, so let's imagine a person. So as I was talking about our AI security project, so we need to find out if someone with the gun, if detected, simply send the notifications. Simply send the notification of that. So we can say like a person detected. We don't need to send the whole video. So each turn video into the events, and as its events and call person detected, send it. If animal detected, send it. So it's not sending the full video streaming. Many of the cases still in a lot of programmers I found out, in those cases they are sending the full video streaming to the cloud. They are analyzing whole videos, and then they are sending back to the response to the REST API like okay, person detected in that particular minutes. But we don't need it. We simply slice it frame by frame, and using Python we can easily slice frame by frame, and then we send back to that particular things to the to back to our REST API. What it happened? It's happened like is make the bandwidth cost too lower. Why I'm talking that? Because why I say the bandwidth cost and things, because as a software developer, as a cloud architect, this is a major problem for us, like how we save to the save like a cost. Because many cases it happen like the software engineer may not think about like what is the server cost, because they don't have to care about it. But as an architect or the product owner, always we need to think about, otherwise the product will not be relevant. So say for example, you are running a business and your business running cost is 100 rupees, but you are charging client 50 rupees. So your business will be in loss. So similar way here, if your server cost is higher than the things you are charging to client for a SaaS based product, then it doesn't have any value. That's the reason you have to switch to this particular pattern. Like you cannot send everything to the cloud and make your AWS or Azure or Google Cloud bill is too high. That's not possible actually. Coming to the pattern 2 actually. So pattern 2 is that local first and cloud sync. That is all we right now using. So local first, let's say you have a POS system, you have a form validations, you have a nodes, everything saved to the local. Even you see like a Trello. If some of you use Trello in your, like a project management tools, or if office also in colleges also you are using Trello, so you will be finding Trello save everything to the locally. Even if you use Slack, so they save everything locally, and after that they send to the cloud. What's the benefit is that? So its benefit is every time they are not calling the REST API and making the REST API calls higher, so we are getting a lot of you can say like a cloud cost over there, and it is not productive as well. So first our goal is that to put like a offline work, so keep local storage and processing. Then if the connection restored, or we may set it up like a daily 1 time, 2 time, or 1 hour, 2 hour to synchronize it. Maybe all the cases is not possible, but for POS system, definitely it may be possible. We save all the things in local and within. Though if POS system, we can send back to the cloud. But there is some positive and negative as well. If your POS system connected with the database, if that particular database also connected to the web, then the operation need to be instant. But if not, then operation doesn't need to be instant. You can make the operations after a certain period of time. That's possible. Or it's always instant, but if internet slow down or something, it can sync. So that's also can be possible. So we put it in a local first and then cloud sync. If you're talking about the web applications, mobile application, or maybe React or something, so they have a local storage over there. Redux is there, Fast API is there. We can keep those records saved into there, and then we sync to the cloud. So that's another way to do. Then coming to the pattern 3, so it's called cascade inference. So there, what we do actually in pattern 3, I will be giving you a simple examples over there in pattern 3. So like your phone. So phone, let's say your phone does a quick face blur. So let's say quick face blur is there. So now if it's unsure, then edge mini server can check it. If still unsure, then we send to cloud to finalize. That way we can step by step we can do it. So if same way like a cache memory concept I was saying. So if it is available in the cache, you fetch back. If it's not, then you process it to the main memory. So here is also the same thing. So you first check it in the edge, and if mini server checks, and if it's sure, then it's okay. If not, then it's sent back to the cloud on the heavy duty model. So this way we can make most of the tasks speedy and most of the tasks more accurate way. Pattern 4 is a very interesting way, which is digital twins. So digital twins is something is right now is very important to say about. So say for example, each of the kiosk or each of the labs, we have a twin. So it means like a twin in cloud. So status and version. So we have like our local storage as status and version, and in the server also status and version. So when we update the copy, so every time we check if we have a version updated or not. This is similar concept like Git. So we check it out if the version is updated, or if the version we have in the local and the version we have in the server, if it is same, so or maybe one version ahead in the local, so we simply update that particular version to the cloud. But if not, then we sync it up from the cloud and we update it. So that's the way we do it. Specifically for the we do it for, we keep it like a logs, we keep the logs properly, so it makes like our data synchronizing properly. So that's one of the concept we use, and that's concept not new, but this is important to maintain for specifically for doc, for data and everything. Coming to the point of pattern 5. So pattern 5 is serverless edge. So we all know about serverless cloud. So, like Lambda, you probably know about it. Lambda is one of the serverless cloud for AWS. So what is serverless? So serverless means like you simply send the data. You don't need to take about the server memories and everything. It automatically based on the computation process, it automatically take the computation. So you don't need to have the failure of the server or anything. That's a great thing in the serverless. So you don't need to think about the computational power and everything. It automatically process it. But there is some of the problems over there as well. Like if you need to make it warm up. Who knows about cloud nicely, they will be syncing on my topic. So basically, you need to warm up the server because mostly for cron job, for scheduler. So let's say birthday notification to send, we use the serverless over there. We don't need EC2s and stuff like that, or server things like that. We simply run our let's say Lambda function over there or a node function over there. It actually check the database. If today is the birthday of let's say some of your teacher, let's say today is the birthday of Mr. Prashanjit or Momita or anyone, so simply send them a birthday notification. So that's kind of thing in a serverless. But now we're talking about serverless of age. What is that actually? So specifically like a form validations, or let's say format validations. So we can have like a we need an instant thing, or let's say you need to fetch the student details instant basis, like let's say the DOB or student password immediately need to verify, or face detection immediately need to verify. So you can do through the serverless of Edge. So that's much more faster and very low latency and is very high. There are some of the positive and negative is there, but still like it you can make it like automatically to scale up over there. So that way you can do it. Now, like is one of the point like AI at the edge. So what is actually I try to mean over there. So many of the time I found one of the specific thing into LinkedIn, like if the red is not turning to green into a signal until unless all people are wearing helmets. So and it's instantly happening. So or maybe the helmet detection need to be done into a factory, so it's instantly need to be done. So we simply can have a small model of helmets into our local system. So camera instantly check, or sensor immediately get, and then it checks from the local. It doesn't need an internet or something. So it simply check and instant reply back through the secure emitter channel, MQTT, socket, or anything. Simply send that. Or let's imagine you need to send the count of a particular person present into a room. So you don't need to send the whole stream to the cloud. You simply check like their images and count like a heads, and then you reply back. So in the AI part, I want to talk about like we can deploy a small model. So model would not be heavy. Model has been trained into the cloud, but the model inference we can put into our edge server, and we keep it over there. Like this is the model inference, and we put into the into our local system, and that can do those all tasks. So that way we can do like a age part over there. Now here is the one of the examples I will be giving you in a real project example. So we were doing a few days back a project, so where the we have to build a system which will be connecting to government API. Is a US based project, so government API to be there, and then face would be detected, and if he doesn't have, if he already there actually, and if he already present in our database, in that case like he has to pass through. And while pass through, also needs to check the updated history of his like a background, like if he has any criminal record or not, if he has any other records or not, everything. So that part also we need to face through it. So how we have done it, so we simply use like the person face put into the our we have made simple Python programs which detect the face. We had a small model deploy, That particular model takes like whether face is correct or not. We save the image into the local and make the person to process through, because we need enough fast. So make the person to the process through. That image we send through a secure channel to the AWS, a REST API been built, actually a Lambda function been built, which actually connected to the government API. It takes some time, like a few minutes, and we simply make the try and catch and get the records. And after that, we giving a proper response to the admin, like this person has still the criminal background verified or not, or if he has a criminal background or not. So that is the way we completed these things. So that is also, using AI and age, we can make the app much more faster. It was a device, it was a kind of a, it's not a desktop app, but a simple device app was there, and it much more faster. Previously, or still like right now, many of the companies or many of the engineers are solving a problem, like send all the information to the cloud, getting the response, criminal verification and everything, and making him pass. But it doesn't require, because if it done that way, then the big problem will happen, because it will take time actually, and it cannot be passed through. So now another important point, which is in AI part, we need to do like a making model small. Many time I talk about like a small LLM. So like there are many companies like Lamha and everyone are doing a small LLM. So we also can do a small LLM part, like, and that small LLM may you can say like it helps. It's more smaller LLM also makes it like help easily. So how we can do it, that's one of the questions. So we can do it like let's say imagine there is a person of let's say a counter which is fit into the Raspberry Pi, and then we can have like pruning and then distillation. So what exactly those terms are, I will be telling you. So basically like in a bigger LLM, we have lot of records been stored, lot of big data sets been trained. Now we can simply put like unnecessary all the thing we can cut off, and then we can simply put like very small or a knowledge bin can transfer to the big to small, and specific those portion we can train. That is way we can build a smaller LLM. So like maybe 7 billion or maybe 11 billion. So we may not need like 50 billion or more than that parameters. Normally who are accustomed with the AI, so they understand what I'm talking about, 7 billion, 11, 13 billion parameters. So specifically the parameters which are bigger, so let's say 50 billion or maybe more than that, 79 billion. So specifically we don't need make those bigger parameter. Instead of that, we simply make a small parameter. So let's say 7 billion or maybe less than that. So those much of parameters we can train, and we only can train with a specific portion. So as an AI scientist, we have to understand like which are the necessary part of that, and unnecessary part we all can cut off and put the necessary part, and make the model train. So this is a options we can do, like making the model small actually. So if we make the model small, then our problem is faster. And if you see a lot of bigger companies, they are actually working to make the model faster, lightweight, because that easily can be synced up with it. So that's one of the examples over there. Now this is something like Edge AI tool and chips. So that part, of course, like another point over there. So let's say I will begin taking the examples of like our AI security, because that project is really a great examples, and we have implemented that, and this is a real need in the market. So basically, let's imagine we are doing their Raspberry Pi with one Onyx model. We are runtime, we are just connecting over there. So what we are doing there, so we are switching like cameras over there, runtime. So maybe like we have there are multiple cameras over there. So let's say 10 cameras over there. We have to switch it through. Or say for example, like another project we are recently doing. So there are let's say a rugby match happening or a basketball match happening. So there are 10, 15 or maybe 5, 6 cameras over there. Now we have to detect the object. So ball is the one of the objects here. So we have to get the feeds from all of the angles. Now or maybe let's say tennis match, I may say, so it will be better, give you a better vision. So in tennis match, what is happening? So we have to send the ball, then ball goes to another court. If it's out of line or if missed, then point should be counted. So if I talk about this, so in that particular portion, what the way we can do? So there are 3-4 cameras over there, and those 3-4 cameras are taking the feeds. Now all the cameras are actually getting the objects, that this is the objects are there. We need to trace that particular objects. Now when the object been traced, actually, then this is the object, and object will be traced. Then what will happen, like simply like when the object been traced, and then there are all the cameras are tracing the object, but let's say there are 4 cameras, there are only 1 camera being traced the object. So we simply need to switch through this. So we may have the device been connected, all the cameras are getting the image feeds, and where the object been detected, that is, we need to do runtime. We cannot send to the cloud again. So maybe Onyx runtime model we can use, which is connecting to the Raspberry Pi, and simply we check the object and we determine, okay, this is the object, and then based on that we can give the points, or we can do that. So that is one of the factor we can use it. Now next thing would be there, like don't drown to the cloud. So that is the part I wanted to send, like talk to, like most of the in the cloud era, when cloud came, so we all was thinking like everything should be retrieve, store, send data to the cloud. But problem statement is that, like, for that, many of the applications right now you can find out is very slow and is not working that great. So that's the reason, again, we are using many lightweight protocol. I was talking about MQTT, or REST for efficient client communication. So we actually start using that, which actually giving the benefit of that, like both like edge and cloud combinedly. So let's say we are storing some records into the local, and then we are analyzing the record into the local, and if it is too heavy, then only we are sending it to the cloud. It's not like we are sending all and everything to the cloud directly. And why this part is important, and you are finding out a lot of requirements are coming that were very good knowledge of gRPC or MQTT, because of like those are specific ways you need to know. It's not like you simply understand those parts, but it's take time. Like it's take time, then you can learn over there. In our, how far I remember, in our bachelor or master syllabus, maybe MQTT not in that vast, but I mean, like socket, socket IO, we train. Similar way, MQTT also we can do. Is Python is very good. Node also it can be used for that. It's very lightweight, and just we need to know, we need to send those things into the secure channel. So that is another examples of that, actually. So we should not be putting through the cloud. We only can send the changes. So say for example, like a temperature. So we only need to send if temperature fluctuate like a 0.5 degree. So it doesn't matter. We don't need to send like all time the temperature. We only will be sending like last temperature, and now if there is a 0.5 difference, then only we'll be sending through. Not like every second we are sending the temperature to the cloud. So that's how we can save that one. Now there is another ways to be this one. So that is like some of the calculation of cameras part I have given. that's self-explanatory, like 10 cameras, 5 Mbps, so as equals to huge GB. But if we are only having a edge detection motion and sense alert only, so we can save like big numbers. So the simple maths, and self-explanatory, that is the way we can save the bandwidth in edge computing. Now I talk about like a container deployment. So some of you already know about Docker, Kubernetes and things, but we can have like a package code with a Docker, and then we can deploy into the into the like different device like a Raspberry Pi or those kind of devices, even other where simple like a Docker container can be deployed. So we don't need like we cannot deploy the raw code, or we should not deploy the raw code, but we can deploy like a Docker container code over there, which actually gives you a benefit, and it can be deployed to the across environment. So we don't need two different environment to be set it up over there. So that kind of deployments we can do. But I will be talking a little more about the architecture part after I put this container slides first. So then like there is another point is there like safe updates. So like it's simple, like I already explained like just like 3 points over there that roll out to the 5% first. So this should be our deployment strategy, and then watch health. Like we will see like a performance. If the performance is fine, it's okay. If not, then roll back. That need to be there. So that is the way we can make the safe updates. And then this is the deployment strategy. But before that, we need to do the development strategy first. Then observe and secure. So that is very important. In cloud also we do like we highly depends on log, metrics and so forth things. And we see the problems early. Here also we observe and securely we can monitors the things. And like of course like a security portions, we have to have like IP to be connected, so we can understand the devices, that whether we are in same devices or not, or maybe some of the cases we can device and TLS, both we can do. And of course like a refresh key and access token should be there, so which has the privilege of least privilege of access key. So this is the way we can make our security hires. That's so far is there. Then I will be talking about some of the case studies, and that's project actually, which you can utilize into your curriculum with the students. So specifically like door camera. So when you will be sending to the cloud and when you will be sending to the edge. So specifically door camera, a visitor being detected, that project you can do into the edge. And then you need to prepare a dashboard of monthly report, like how many student has come or which student has how many days present. So those you can do through cloud. So that is one of the smart campus project you can do through edge and cloud combinedly, and make sure and show like what is the difference, like whether why we'll use edge and why we'll use cloud. It's a very simple and easy project to be done. That is one of my interesting, one of the hospitals we are doing that actually. So we are building a products where like we are checking the heart rate. So one of the US companies, they are building a products of checking the heart rate. Now there is when the spike is happening, simply the age alarms are coming, and once the age alarms are coming and sending back to the the respective department to monitor, but cloud after that is running and checking out the risk. If the risk is there, then again sending the alert to the the higher department. So that is the way. So we simply in an age, we simply checking in a millisecond like spike is happening, and once the spike been those record we are sending to the cloud, and then our machine learning models are detecting like whether this has a risk or not, or based on his health condition, if this has a risk, then only it's sending to the hospital like authority or nurse or doctors. If not, then it's keeping up. So that is the way. Another case studies that may not be possible to execute into the maybe college, but that is also another projects to be done. Now this is interesting, like a retail queue, and I will insist, like, if you also can build the projects nicely with the students. So like counter stuff. So it's most of the problem happen like specific counter, or sorry, in a specific portion, let's say relay counters, or into the you can say like into the restaurant. So if we can have like a or in a billing counter, so many time in smart bazaar and those portions, like we find out like there is a shortage of billing people over there. So simply we check the count and we send alert to the authority, like you have that much of people, but we don't have the enough person into the billing. So that may be a revenue loss. So you simply alert them, and then you can ask them that if you put more person or open more counter over there. So that also can be there, but the dashboard preparation and things we can do like a Power BI or something. So preparing that, which is simply you connect like a cloud with database with the Power BI dashboard. So this is the way we can. This is also a good case studies to be there. Then the Okay, then the precision farming is there. So that is, I have it is a simple project, like I have done it before, and we have done it for like soil moisturing. So we have a sensor and things, or weather data. We simply have like a soil moisturing to get, and then put the decision. It doesn't need like a um, cloud, but of course like an analytic part you need to the cloud. So that is also you can use as a real project, and very demanding project right now over there. Now my point is that why we will be doing so many things, why we'll be putting extra thing age over there, because this is actually helping us to reduce the bandwidth. That's only the reason we do. No more reason over there. Of course, like a bandwidth and the latency issues will be lower, and of course, like we will be having easy way to more and more devices we can manage, and so complexity would be less, and we have the very speedy kind of output we can show. That's the reason we will be using that. Safety part, of course, there is an important, like whether we need to how much safety and things like that. That is important point. So of course, like local saving is much more safety, but you need to send it to the cloud, of course, for making a fast. But you are just sending the not the whole data. Specifically, if you are working with finance data, if you are working healthcare data, so there are a lot of compliance over there, and those compliance to do with, you don't need to send the whole data. Rather, you simply send the params like counts, the output and stuff like that. So you don't need to send those data directly to the cloud, because if you send those data, you have to anonymize those data, but you don't need to do, because you are only sending the pointers over there. So that's the way I say, like, age is little bit safety and things. So this is almost the part. Before wrapping up, I will talk about the architecture part, but in a short, like, age is reflex, cloud is memory plus wisdom. But that's so far in my point of view, that why we should do. But if you have any questions, I can answer before I talk about the how we can do the architecture part over there. It may take another 5 to 10 minutes. But if you have any questions so far, I can
Yes,
just answer here. Go ahead.
Chandan sir, please go ahead. Sir, we have a question in the chat box. How do you manage different hardware architectures of edge devices?
Okay, so there are there are different ways to be done. So there are few of the ways I can see you that it's possible to do, or how we should do. So let's come one of the answers. So say for example, like just give me a moment. Okay. So okay. So you're where you have sent the question in the chat?
Yes, sir. The question is available in the chat. It is
Okay,
asked
let
by
me.
our Prashanit sir.
Oh, okay. Oh, yes, great. So I got the questions here. So I would be answering through a little bit of analytics way, so you can understand like hardware architecture part specifically. So first of all, I like to say like if I talk about the hardware architecture part, so specifically in the hardware architecture, there are different things we can use it. So specifically like GPUs are there. Sorry, anyone want to ask anything? Okay, so I'm putting the part over here. So say for example, like we have different hardware is there. So let's say GPUs are there, NPUs are there, microcontroller are there. There are different hardwares are there. Now, how do you how we should manage that particular different hardware architecture? So there are different ways we can do. One is like we can use like container and packaging. So say for example, like we can package our app into a Docker containers, or we can build like a Docker images, and then we can deploy it for both, like let's say ARM65, Raspberry Pi, Jetson. So both cases we can deploy this. So how we can do like simple a Python app we can package into the Docker runs, and then we deploy to the both. That's number one. Another point we can do like abstract the hardware differences. Like I talk about like a 1x runtime model. So that is also we can do, or TensorFlow Lite we can use. That is the way we can abstract the hardware devices. But my suggestion would be first options to be put up over there. Simple like use the containerizing packaging, or we can use like K3s like Qubit. So like a lightweight orchestration, we can use it. So simply like we deploy the lightweight inference services only. So that's the way we can you can say like we can make the different hardware architecture into the edge devices. You got it? Any specific follow-up questions from there?
Participant, if you want to ask any question, please you can unmute yourself and ask directly to the sir, or you can put your question in
Yeah, put
chat
it
box.
question in chat, so it would be good, so I can read properly. Yeah.
Yes, sir.
Yes, sir. I have one question. How can we integrate the edge computing with the cloud infrastructure?
Okay. So yeah, so there are also several ways to be done, like edge computing and cloud infrastructure. So I will be also giving an examples. Let me find from my PPT one good examples are there. Just a moment. No, I think I don't put that one there, but no, I didn't put anything with them. Okay, but I can little bit explain you like edge computing in the cloud infrastructure over there. So there are several ways we can do it. It's there are options are there, but first of all, I just try to give like an examples over there just to give you a proper understanding. Just give me a moment. Just I'm finding out if I have like any examples I have put into the PPT. One moment, ma'am. I'm just finding so I can give you a proper examples that how can we do that. Okay, so No. Okay. So there are edge computing, if we wanted to put into the cloud infrastructure, I didn't put into my slide, so I can little bit, I was just finding out a proper example. But if I try to put like a edge computing into the cloud infrastructure, so there are different models over there. Like we do one of the example into the cloud infrastructure, we do serverless. Like I talked about, like there are different serverless using AWS Lambda we can use. In Google also the cloud infrastructure over there. So if we want to do that way, so there are also factor over there, like we can make the serverless edge infrastructure. So that is we can deploy it, or we can deploy it into the local infrastructures. So again, for the local infrastructure or into the cloud infrastructure, we simply can use like Docker containers, and that will be helping us to make it faster ways to do, and our local model, and the cloud, the latency we get into the cloud local model, we may get the faster ways to be executed. So that's the way we can deploy it. And the communication channels between the cloud infrastructures and edge, we can simply put like a different medium, not like a direct REST API, because sometimes it will be slow, but we can do like infrastructure, like channelizing it, like socket we can use, MQTT we can use. So just notification and response, and send back and send forth. So that we can use.
So that means we are using some interfacing devices in between them.
Yes, of course. Otherwise,
Hmm.
that won't be a exact possibilities, because edge is all about that. There obviously there would be interfacing devices between them, or we can put through the response channel. So secure channel, we can send the response back and forth.
So is it hardware or is it software? Those
Mostly
interfacing
hardware.
devices?
Mostly the hardware devices. Software devices
Okay.
cannot be put. Yeah.
Okay. Okay. Thank you very much, sir.
Thank you.
Participate, any more questions? Shoma ma'am, then can we conclude this session?
I think sir will discuss regarding some architecture. No?
Yeah, so that part I just wanted to talk about. It will take few more minutes, like
Okay, sir.
architecture point of view. So what kind of architectures we can use it actually. So because this will be helping you into the coding part. So let me talk about the architecture portion. I haven't put into the slides because I have thought it in a bit of last moments, like how I can little bit talk through it, like so you can decide the architecture points, like how we can do it. So basically, like for this architecture we need a few things. One is like we have to have like a cloud infrastructures over there, which is one of the important point of doing these architectures. And second thing is that programming language. So programming language, we may have to use like Python, which is one of the important point. We need to have the Python as well, to teach them through. Then another is the web app data path, where we can use like a HTTP or REST, MQTT, WebSocket, gRPC. It's a maybe heavy term, but some of you already know about it, like MQTT, HTTP. So HTTP REST is one of the important. Then MQTT for the devices we can use it, like for cloud messaging and things. Then socket and gRPC we can use for a where you need a streaming. Then we can use the socket and WebSocket or gRPC. And this normally need to be there. For the local storages, we all know like SQLites we can use, or maybe InfluxDB we can use, like time series DB. Those need to be trained to the student for the process. So, and while you are writing the app, simply you can, for the Edge app, you can simply use like One is like a ingestion. So ingestion is like maybe you are using OpenCV or GStreamer for video. Those you, or for the sensor you can use like a HTTP or MQTT or serial for the sensors. You are getting the data, you ingest those, and then there is a decider. So like let's say if Q it greater than 10, so alert, send the alert. So that way we can do this sending alert again. You can do through like those channels. And last, like publish the small events, like this is the events been there, maybe not whole raw stream. This is the few catch, please take a note. Like I mean, that's makes you a different between cloud and edge. You don't send the whole records. Edge always never send the whole record. It simply send those particular events. So your mindset would be the event driven strategy. So let's imagine there are someone in the queue is more than 10 people. You send the alert. So you only send the alert. You don't send like a raw footage of that 10 people's. So that's an important point. If you send the raw footage, then your edge, building app with edge has no value. Now there can be a process through the watchdog. Watchdog process can be used, or maybe which we can talk about the logs. Logs can be used over there to check it out if network is slow or not. If network is slow is happening, so we need to more filterize the data. So that's the way you can do a simple, age app. So while you are doing in the college a simple age app, you put 2-3 factor. One is like how to send the data.
1 minute,
Number
sir.
one, yeah.
Yeah, are you presenting something?
No, actually, sorry, sir. Actually, I didn't put that. I didn't present something over there because I didn't put into the slide. But later on, I thought like, as a teacher, you need to understand that how you can build a live project over there. That's the reason I'm just explaining that part. Okay.
Sir, do you have any a diagram like that so that you can share later?
Yeah, I will be sharing maybe a small project also I can share with you, that you can, a
Okay.
small project that you can show your college as a POC, proof of concept you can share. So 2-3 small project I have done it recently as a proof of concept for our, for our client. Those are doesn't have any ND or anything. I will be sharing those. So one example are like a simple like a camera detection app. So you see there are 10 people over there. You simply get the events of 10 people over there and show the alert. You don't send the whole stream or whole images of the 10 people. That is important point. I mean, while building those age app, we have to make sure that as low as data we need to send, not like a whole data we should send. So that's number one point we can find out. Another thing is that security. So security part we have to understand, and basic security we need to do, like unique device identity, because in a age app is very near to the devices. So device identity is very important. I said into the slides as well, like device identity is important, like IP or device unique number, that should be important. And when you are sending the traffic over MQTT over TLS, so that time also you need to make sure it's very easy and it doesn't have any other problems. And then less privileged keys you have to use, like in the REST API. Let's say you are using auth0 or any other verification channel. So those are cloud here. But here in the edge we simply put like a less privileged keys. So, and that's rotated regularly. In cloud also we have refresh token. Similar concept here, we have the less privileged key. And number four thing is the firewalls. Like firewalls is the close all the port except needed. We don't open all the ports. We simply keep the ports, put over there. While working with Disney, Amazon, one of those, so we used to have all the ports open, but they have, while working with them, I learned from them, like we cannot open all the ports. Only we should open all the port which is essential. So that's all needs to be there. And last thing is that like data encryptions. So as we are working with the devices into the public areas, so all data should be encrypted before saving into the local or transmitting to the into the cloud. So that should be there. I can send you some of the projects maybe in the next week. I think Prashant said is connected with my WhatsApp, so he can just one time get me. So I can send some projects so which you can show. This is a real project, so small version of our copy, so you can show to the student, and you may also get some help from there. That would be handy for students. So that was the architecture mostly I was covering. Like one is security, and second is that the guidelines for building app. Like never send the whole data, just send the transmit the keys. Well, that's all from my end. Thanks all of you to giving your hectic schedule. I understand, as a working professional, I understand how hectic it is, but still you give so many time, so patiently listen. It's great. So anything you want, simply you can reach out to me, and I can send as much as possible in mind the data points. Mine's all done. If any one of you wants to talk anything.
Yeah, thank you very much, sir, for your valuable insights on the sandwich, that is the synergizing cloud and the edge. So you describe the things very clearly, and we get the clear concept about the cloud computing as well as the edge computing and how they are integrating. So I hope this session has sparked ideas and collaborations that will drive innovations in this exciting domain. So thank you very much, sir.
Thank you so much.
So
Thanks for your time.
yeah.
Have a
So
lovely
thank you
day.
very yeah.
Thank you.
Thank you,
Thank
sir.
you. Bye.
Bye. Good night.
Good night.
So thank you very much to all the participants for your kind patience. So Sumit sir, please.